Hi everyone, today we are talking about equations for inverse functions. What we're going to start is we are going to take a look at f of x equals 3x plus 2, and we're going to change it into f of negative 1, which is the inverse function notation, equals x minus 2 over 3. And I will show you the step how to do that. Finding an equation of an inverse of a model, you need to think about it this way. Consider the following sequence of steps that many people go through in the morning. You put on socks, then you put on shoes, and you tie your shoes. What sequence of steps would one need to do to undo those steps? The steps you take to undo the steps above is untie your shoes, take off your shoes, and take off your socks. How is this sequence of undoing steps related to sequence of doing steps? Example number 1. Find the f inverse of fx equals 2x plus 4. Step number 1, we are going to take f of x and change it into y equals fx equals 2x. I'm going to write down the step and I'm going to explain it. Example number 1, as we follow through the steps, I copy down the problem, fx equals 2x plus 4. And I change fx to y equals 2x plus 4. Then I swap x and y, the x become y, the y become x. X equals 2y plus 4. That's the second step. Then solve for y. So I rewrite the equation again. X equals 2y plus 4. Then I minus 4 on both sides. I will have x minus 4 equals 2y. Divide by 2 on each term. I get y equals x over 2. Negative 4 divided by 2 gives you a negative 2. And that will be my new equation. F of the inverse of x equals x over 2 minus 2. That's my new equation. Next thing is the undoing function in the mathematics is called the inverse function. That's what we do. F of the inverse. The notation for the inverse function is f of negative 1. And that's how we write it on the equation above. So now I want you guys to fill in the tables below for f of x equals 2x plus 4 and work it out. That's a f of inverse x minus 4 over 2. That's the same thing as the problem right here, x minus 4 over 2. I just simplified it. It doesn't make that big of a difference. So either way will work. So please now fill in the numbers for each table. Let's take a look at the table. If you are giving original equation 2x plus 4, after you filled it out, here's your answers, 0, 2, 4, 6, 8. Now look at the inverse. What is going on with the inverse on the order pair? If you have negative 2, 0, it becomes 0, negative 2. If you have negative 1, 2, it becomes 2 and negative 1. 0, 4, 4, 0, and so forth. That tells you both x and y are just flipped. So now keep that in mind when we move on to the following problems. For example number 2, let ft equals 12.1t plus 14 be a linear model to predict the number of worldwide emails sent daily in billions to t years since 2000. A, they just want you to find the inverse of the function. So I show you the steps, and there's f of inverse equals t minus 14 over 12.1. Don't forget the steps are I change that to y, I swap the x, the t, and the y. T is like the x. I solve it for y, get the y by itself. Letter B. First of all, they just want you to find from the original equation and then interpret the results in the context. So in this case, I plug in the original equation, I get this number 195.5. To interpret this is in 2015, because 15 is since 2000. 195.5 billions of emails were sent all over the world. That's the interpretation. C, when they say find f inverse 210, interpret the results in context. That means if you send out 210 email, how many years is that gonna take? So f of 210 email, and then plug into the equation, you get how many years? Because we had to round up the years. If you do 16, it will never reach 210 emails. So we rounded up in 2017, more than 210 billion emails were sent all over the world. Letter D. What is the slope of f? Please don't forget your unit. Interpret these results in the context. 12.1 billion emails per year, and that's why they have 12.1 over 1. So next one, the slope is 12.1 billion email per year. E. What is the slope of f inverse. And when you're talking about inverse, interpret the results. Once I figure out and I split the slope into two different parts, that's mx plus b. There's your mx. So in this case, t. So the slope is really 1 over 12.1. To interpret, is this 1 in 1 year, 12.1 billion email were sent over the world. So that is example number 2. Please finish example number 3 as your homework. I will not discuss it, and if you have any question, please ask. But that I would like to save that as your, if a graph of a relation passed the vertical line test, then the relation is a function. If a graph of a relation also passed the horizontal line test, then the inverse relation will also be a function. So that is what they have for the next thing. So going on to the next one, let's take a look at all the different vertical line tests and see, can we decide horizontal line test or a vertical line test. For example number 3, don't forget what we read above. If you have a vertical line test, it's a function. But if you have a horizontal line test, that means the inverse function will also is a function. We are testing vertical line, and vertical line test is going to be a path. And vertical line test is just saying if you draw a line down, you only meet the curve at one place. Doesn't matter how high up it goes, you still only touch at one place if you draw a line. Now, horizontal line path, does that pass? Let's take a look. If I draw the horizontal line this way, doesn't matter how close this is, it's still going this way, but there's going to be another line comes through. So horizontal line also pass. This is an inverse function, definitely work. Is this a yes or no? You guys decide and come back and check your answer. So for letter B, it's yes, vertical line passed, and horizontal line passed. That's a horizontal and this is vertical, so they both works. Then the next one, the vertical line test pass, but if you look at horizontal, I hit 2 points. Horizontal line does not pass. This is not an inverse function. The question says, how can you tell by looking at the graph that f of -1 exists? And the reason I can just look at the graph is horizontal line testing. How can you tell by looking at the graph that the inverse function exists? The inverse function exists because the graph passes the horizontal line test. The objectives for 6.10 is the inverse models. Let's take a look at the inverse models. There's 3 different ones. If you have a line right here, it's going to be flip over. If you have the line this way, it's going to be this way. If you have a line going this way, it's going to be this way. You just know X and Y is flipped. So let's take a look at the question it's asking. Example number 1, use the data below to answer the following question. Here's my data. The years is 1988. The number of polio cases is 350 in thousands. So let's take a look. What are some of the questions asking? Find a linear model for T, where T is the number of years since 1980. So in this case, we have to put our data in the calculator and come up with the equations and find out what is my year. So pause your video, punch in your data, and find me a linear regression equation. Example 1, to find the linear model and the quadratic model and exponential model. I would like you guys to answer all the questions because we cover all this, and then I'm gonna do the whole thing and we are going to spend a little time talking about it. So just go through the example, punch in the calculator. The first one, I use the linear regression model, so that's number 4 in your calculate, and then those are the numbers. I write down my equation. The next one, I use the quadratic model, and then therefore that's number 5. And notice I have all my R value, and that's R squared. Finding the exponential model, that is the 0, and those are my value, and notice my R squared. Letter D says that which model seems to fit the best? Well, the quadratic definitely fits the best. Look at how close to 1 is the R squared value. I went on and say, okay, since that is the closest one model that we should use, I'm gonna try to use that one to predict the number of polio cases in 2013. Now, if I put in the work, the 2013 is gonna be 33 years because that's 2013 minus 1980 because that's the years that we started taking the calculation. That's 33 years. So I'm putting in 33 for all my T's. And then that is 187 cases and 187 37.95 thousand cases of polio after 33 years. Now think about this. Quadratic equation is actually a parabola. It goes down to a certain point, it will have to come up. So that is probably not the best equation to use because cases will decrease and just get less and less and then almost non-exist. So then therefore I'm gonna go on to use exponential model. So here's my exponential model calculation. So after I do the calculation, I use the exponential model. I plug in the t for 33 and there's 0.198 thousand polio cases left after 33 years. So I really prefer this number better. The polio cases just gets less and less. Next thing, F. Compute 0001 negative 1. That means that's an inverse. That is how many cases is left. And we want you to find the number of year that's possible. So interpret what this means in the context. I am going to put my equation in the y equal, and I'm going to use the table like I show you guys to do it from the previous problems. So look for 0.001 on your x column. So use your number to scroll up and down to find about 0.001. And that's actually between 50 years and the next number. I think 50 years is a little bit closer. So 50 years is go down to 0.001 cases. So from the 1980 is when we start taking the data plus 50, that gives us 2030. So in year 2030, the polio cases will go down to 0.001 cases in 2030. Going on to the next problem. Find the approximate half-life of the number of polios. Half-life is, don't forget, half-life is half of the initial value. So initial value, let's look at the equation. Initial value is going to be the very first number. That's the A, 3739. So we are going to just drop that was 0.7. So using 3739, half of the life is going to be 3739 divided by 2. That's about 1,869.5 thousand cases. I'm using the little table again, using the equation previously already entered. I scroll around. The t come down to be between 1869, between the second and the third years after 1980. So therefore, that is half-life in 2 to 3 years. So the decreasing of the polio cases goes down by half every 2-3 years. But there's always going to be 1-2 cases just not going to disappear. Hopefully one day they will happen. But I'm just saying by statistic mathematical situation, it goes down about 2 to 3 years, half of the cases. So that's a wonderful thing. So there is t is between 2 to 3 years after 1980. Okay, and this is example number 1. And that concludes the notes for today. Thank you so much for watching.